Hello everyone, welcome again in the lecture of IC engine fuel and lubricants. This lecture will be dedicated on engine cooling part 2. In previous lecture we have discussed the need of the engine cooling system, what is engine cooling system and why it is needed for the cooling purpose of the engine, its merits and different types of the engine cooling system we have discussed. Now, in this lecture we will discuss parts of liquid or water cooling system, radiators and cooling fans, comparison between air cooled and water cooled engines, determining cooling system capacity and we will do some numerical exercise on the cooling system. So, the engine cooling system, why it is needed? For two purpose mainly it is needed to protect the lubrication film around the different components, so that the engine friction is controlled, and another one to sustain the metallurgical limit of the engine components. If it will not happen, the engine may get seize. So, it should be there, engine cooling should be there, but at the same time it should be effective also. So, the operating an engine below a certain lower temperature also will cause loss of thermal efficiency. You all know that what is thermal efficiency. So, loss of thermal efficiency will be there. Incomplete evaporation of fuel. Incomplete evaporation means the fuel and air mixture, if that cooling is not effective, the fuel will not evaporate in a required interval of time, and if it is not evaporated, it will not mixed with the air molecules, and there will the final effect is on the mileage of the engine as well as on the emissions of the engine. So, the incomplete evaporation of fuel should not be there. Fuel should be evaporated in a required interval of time. Another one is appearance of fuel droplets on cylinder wall and the piston. If the operating of an engine below a certain lower temperature occurs, then you will feel some fuel droplets on cylinder wall and the piston wall. Passing of fuel droplets, these fuel droplets which are collected over the cylinder wall and the piston, they are passed to the crankcase, and the result is the dilution of the lubricating oil film, because it passes through the piston rings. And we have also discussed, because of the incomplete evaporation of fuel, higher fuel consumption will be there. It disturbs the mileage and performance of the engine, as well as not only the performance, it also affects the emissions of the engine. And because of the effect on the lubricating oil film, if proper effective cooling is not there, then increased wear of cylinder and top piston rings will be there. You can see in the diagram that this is the water outlet temperature and these are the fuel economy. So, you can see that if the water outlet temperature, I am discussing the case for the liquid or water cooling system. So, the liquid and water cooling system, what is happening? The water is coming with some temperature, let this is your cylinder and this is the some jackets provided around the system. These are the jackets through which the water is flowing around the circumference, and this is coming out from different passages. So, this temperature at which the water is coming, let this temperature is TWI, I, TWI represents the water inlet temperature, and the temperature at which it comes out is TWO. TWO stands for water temperature or outlet water temperature. So, as per IS standard, the performance of the engine is measured in terms of the outlet temperature of cooled water. It is limited. It is not like that you are cooling engine, it's your not choice. It is controlled by some standards. These are IS standards, have its codes like 1100 something else there is code. So, it controls that. This is the check on the outlet water temperature. So, that is why I have taken here as TW on x axis. So, if the speed of the engine is 50 kilometer per hour, then for outlet temperature 50, there will be fuel economy is normal, and if you increase the outlet temperature as 60, then the fuel economy disturbed by an amount approximately 2%. So, this 2% is improved for the same speed. You are running an engine on same speed, but you disturb the outlet temperature by either using some pump or you increase the flow rate, you control that outlet water temperature, and if you increase that outlet temperature as 60, then the fuel economy is increased by approximately 2%. Similarly, for 70, it is further increased. So, for this engine, this much is better, because the design value is 50. So, for the each engine, that may be stationary engine, that may be automotive engine, this outlet temperature is designed, it should be nearby the designed value. Similarly, you can see if you increase the speed from 50 to 115, same engine 115 kilometer per hour you are running the engine, then this limit is further disturbed. How? Here the this temperature, let us between 60 and 70, let us it is 65. So, 65 is better, but if you improve the TWA to 80, then this will be the extra fuel mileage. So, this TWA depend upon the also the different variables of the engine, like its speeds, its RPM, etc. Similarly, you can see in this diagram, it is cylinder wall temperature TWO, and here is this is wear, tear and wear of the piston ring. So, it has been found that this is trend is like this, and cylinder initially it was wear was this much, but as you increasing the this outlet temperature, disturbing the outlet temperature, this tear and wear is affected. So, tear and wear as well as the mileage of the engine affected by controlling this outlet temperature. Now, comes to the parts of liquid cooling system. So, three major components of the liquid cooling system we have discussed. These are the water pump, cooling fan, radiator. These are the main components: water pump, cooling fan, radiator, and other components are also there, like radiator cap, thermostat, lower and upper hose connections, and pulley and belt. So, water pump, you all know that it is centrifugal type of pump, generally mounted at the front of cylinder block, and why it is used? For the forced circulation of water inside the engine. In last lecture, I have shown you the slide for the water pump forced circulation cooling of the engine. So, water pump, then cooling fan. So, it serves two purposes. It draws the atmospheric air through radiator and thus increasing the efficiency of radiator in cooling hot water. So, radiator is that part, here radiator is that part which is used like it is a heat exchanger. So, it increases the efficiency of that heat engine, and it fan is that part which throw air on the tubes of the radiator. So, to drive this cooling fan, the partial work is taken from the engine. So, it throws fresh air over the outer surface of engine, which takes away the heat conducted by engine parts and thus increases the cooling efficiency. These are the part of liquid, you can see this part of liquid cooling systems, different parts. You can see this is this part is hose from heater, this is hose pipe. This is bottom radiator hose pipe, this part is fan, these are blades of the fan, and it you can see here this is taking energy from the engine itself to drive this fan. So, fan power is partially taken from the engine, and this is water pump here, this is water pump, this part is water pump, coolant filter, either liquid or another coolant can be filled with the help opening this knob, and these are the tank, this is top radiator hose, and this is the lower tank, this is the upper tank, and this is the radiator cores, finned cores in fact. So, these are the components, and here also the thermostat valve is opened by the wax inside melting, this is somewhere else, this is thermostat valves are there also, and these are the channels provided for the flow of the water. So, this is the 3D picture of the liquid cooling system. So, continuing the parts of the liquid cooling system. So, first two parts I have discussed, these are the first two parts, water pump and cooling system. Now, the radiator. So, radiator is a cross flow type heat exchanger. So, already you have been taught in the heat transfer parallel flow heat exchanger and counter flow heat exchanger. So, third type is cross flow heat exchanger. So, radiator is a cross flow type heat exchanger used in the IC engine. It consists of two tanks, one is called upper tank, in last picture I have shown you the upper tank, and the other one is called the lower tank, and bunch of tubes are connected to both tanks. The upper tank is connected with the exit channel of the engine jackets via hose pipe, and bottom tank is connected with the entry channel of the cooling jacket via a water pump. Hot water from the upper tank flow downwards through tubes. The heat contained in hot water is conducted to copper fins provided around the tubes. So, here you can see this is frontal shape of the car, and this part is called cooling system, or this part is in fact radiator. So, an efficient radiator should have the following qualities. It must be light in weight, because you have to use this radiator into your automotive vehicles. So, it should be light. It must be corrosion resistant, as it is operated with some water and other additives, coolants. So, it should be have its for its own life, it should be corrosion resistant. It should have as much as possible cooling surface exposed to the surrounded air. So, surface area will be improved. So, heat transfer rate will be improved. It should have sufficient strength to sustain the shocks, because when the automotive vehicle will move, so it will have shocks during its travel. So, it should be shock free, it should be able to sustain these shocks. It should be leak proof. So, there is no loss of circulating water also. Its material must have higher thermal conductivity. So, higher the thermal conductivity, higher will be its H, value of H and heat transfer rate. Another part is radiator pressure cap. So, what is radiator pressure cap? You know that it controls the leakage of the radiator to control its pressure. You know that if you are using water as the working substance, it boils at 100 degree Celsius. At you know that the 100 degree Celsius is the temperature of boiling of water at 1 atmospheric condition, and if your vehicle is moving some hilly terrains, hilly area, then the pressure, atmospheric pressure goes down. If there is leakage, then water will not take 100 degree Celsius to boil. It may be boil according to its atmospheric pressure condition, it may boil at 60 degree Celsius, 70 degree Celsius. So, steam will be formed after boiling of the water, and this steam may it is not desirable, it resists the flow of water inside the hose pipes. So, it prevents, so radiator pressure cap, why it is used? It prevents surge or spill losses and water evaporation, improves the cooling efficiency of the engine. It also prevents boiling of circulating water at 100 degree Celsius in plain regions and below 100 degree Celsius on hilly areas. It also prevents exposure of water to the sun and thus saves water loss due to evaporation. So, it is a very tight pressure cap used for radiator. Now, come to the another part, very important part, thermostat. Thermostat is a thermostatic valve, means it operated with in the function of the temperature, means valve is operated at a particular range of the temperature. So, when cooling is not desirable, just like you are starting your vehicle, cooling is not desirable, that time there should be some heat also. So, cooling is not desirable, cooling is desirable after some interval of time. So, it starts as that time is achieved, means time is at that temperature, just the valve is open and the circulation of water is started. So, it is a flow controlling valve used to maintain the temperature of circulating water within the stipulated range. That range may differ for different types of engine. For example, it is for a stationary engine, it is for a small capacity engine, it is 75 to 85 degrees Celsius. So, where it is located? It is located in the delivery side of the water pump or water outlet connection. So, this is the location, and different types are below type. Again this it is divided as sleeve valve type, butterfly valve type, etc. And another one is wax pellet type, this is B. So, A is below type and wax pellet type. So, you can see here the opening, percentage opening of the thermostatic valve with respect to circulating water temperature. So, if the circulating water temperature TWO, if it is achieved at 80 degree Celsius, then this valve will be opened approximately 45%. This is the percentage open of the valve, and if it is achieved at that circulating water temperature increased to 85 degrees Celsius, now suddenly what will happen? This valve is thermostatically controlled. So, it is opened 100%. So, at this temperature valve will be open 100%. So, suddenly the cooling rate will be improved. Now, the comparison between air cooled and water cooled engines. So, one by one we will discuss it. So, this is basis of the outer construction of cylinder. So, air cooled is finned to increase the heat transfer dissipating surface. And for water cooling it is normal. Natural draught, natural circulation of air, and it is insufficient inside a closed engine compartment. provision for forced draft. So, in forced air cooling engines, this is tilted and fan pushes the air on the off for cooling purposes. So, here in forced draft condition we use some fan. Similarly, here we use some blower or fan. Immunity against freezing or boiling of coolant, because we are not using any coolant here. So, there is no chance of this type of freezing of the coolant. And here in water cooling, here some exist, therefore, anti-freeze chemicals are added. Boiling temperature of water is raised by using a radiator pressure cap. We have discussed this. The boiling point is improved high by the help of radiator pressure cap. Then number of accessories and spares, here in air cooled very less, and here there are many components we have discussed like fan, pump and radiator cap, thermostat valve, pulleys, etc. Maintenance negligible, here more component, more maintenance. Space very less, here more components, so more space is required. Temperature control depends on the air flow. If your vehicle is moving with low velocity, then the heat dissipation rate will be lesser. If you are moving the vehicle in higher velocity, the heat dissipation rate will be higher, but here it is better because we are using liquid as well as air. So, operating temperature range is higher for the air cooled engine, and here it is lower. Clearance between moving parts to allow the expansion, here the clearance is higher, here clearance is less because we are using more components. So, this was all about the comparison between air cooled and water cooled engines. Now, another topic, determining the cooling system capacity. So, determining the cooling system capacity, the capacity of water or liquid cooling system is generally expressed in terms of coolant circulating through it, in terms of coolant circulating through it. So, the coolant may be your water also. Let I am taking the case of water cooling system. So, the for water cooling system, let mass is given, T1 and T2 are the inlet and outlet, Q is the total heat dissipated through the water. So, you all know that this is the working principle of it, heat given by the engine is equal to heat absorbed by the water. So, Q is equal to ms delta T, let this is equation 1. Similarly, where S is specific heat, value specific heat is 4.18 kilojoule per kilogram Kelvin, T1 normally taken as ambient surrounding temperature. The mass water equation 1 is related to its volume of flowing. So, mass is equal to this rho is density of water. So, rho into V equation 2, where rho is the density of water, where it is taken as 1000 and this volume is related to the area of flow. So, volume is equal to, this is the formula for it, let equation is 3. The equation 4. So, calculation of radiator pipe size, since there are n pipes, each diameter L carrying water through a radiator, therefore, area is equal to number of pipes into area, one tube area is pi by 4 into d square. Once diameter of pipe is determined, the capacity of water contained in them can be obtained by this formula, pi by 4 d square into L. This is the capacity of water, water is flowing through all the tubes. So, in a radiator water also remains in continuous flow. So, we take more than this value, it is approximately 1.5 times higher than this value. It is your designed value, this is the designed value, This I will take an example of it, a 4 cylinder water cooled engine having 80 mm stroke 70 mm, these all the parameters are given. So, heat released by the fuel is equal to 15.6, it is given 15.6 kg of fuel per hour. So, we convert it into per minute into its this calorific value of the fuel, kilocalorie per kg. So, it comes out this much amount. So, it is the heat, total heat released by burning of 15.6 kilogram of fuel per hour, because this only 10% is amount of heat energy transferred to the cylinder wall. So, 10% goes to the cylinder wall. So, we have to remove it. So, this heat transfer occurs from total surface n into pi d L, this is the radiator, number of tubes, number of sorry this is number of cylinders. So, 4 cylinder, one cylinder size is given. So, this area, total area of the cylinder comes out here. Now, we will apply, because the cylinder heat transfer through this solid medium. So, we will apply Fourier's law, Q is equal to minus K del T dt over dA. All the values are given, you will put that value and temperature drop is evaluated by this equation. So, this is the inner boundary, this is the outer boundary. So, we are able to find this 5.85 here degree Celsius. Now, the temperature drop from the cylinder wall to the cooling water is determined from equation, this equation, in which H is this. So, we will apply this equation, Q is equal to H A delta T. So, this with the help of this you can evaluate the value of delta T. Now, this problem similarly we can solve here. From this problem we will apply this equation, mass carry away by the water, Q is equal to m s delta T, and the volume is calculated by the formula rho into V, and because we have taken 1.5 times extra, V is equal to N A into V, N A into V. If we putting all the values are given here. The diameter comes out 19.63. All the parameters is given. This problem was based upon the capacity of the capacity like this. All the formula here are I have discussed. So, this is this problem is based on the capacity of water or liquid cooling system is determination of that. So, in this lecture I have discussed the different components of the engine cooling system and why the merits of those different components and the capacity evaluation, and we have done some numerical problem on the engine cooling system. So, thank you so much.